anyone can probably produce a part with enough time, effort, resources, and energy to get one really amazing part out of the system. But then when you go to scale, it's like, oh yeah, it took us a week to depowder this thing correctly and another week to get it machined. And then, okay, now we have to do 20 of those or 30 of those or more a month. How does that look and how does that work? And often it doesn't. The economies just aren't there. So I think taking in all those considerations from the beginning and choosing pilot programs that are scalable in that way is the customers that succeed.
Welcome to the Additive Advantage Podcast, where we cut through the hype and talk about what it really takes to turn additive manufacturing into real business results. I'm Sean Anderson, and this is my co-host, Danny Mason. Together, we bring decades of experience in technology and additive manufacturing to explore how organizations are moving from pilot projects to scalable, performance-driven additive capabilities. Let's get started.
Today, we sit down with Adam Simons, Head of Sales and Applications for North America at ATLIX, formerly TRUMPF Additive Manufacturing. We unpack what's actually changing in laser powder bed fusion today, what separates scalable programs from pilot purgatory, and why the future of additive has less to do with cool machines and more to do with process discipline, workforce readiness, and operational maturity. If you're a manufacturing leader trying to move additive from experimentation into real production impact, this is a conversation you need to hear. Well, it's great to have you on, Adam. I've been looking forward to the conversation we're going to have today. And I think a great place to start is, could you just introduce yourself and a little bit about ATLIX?
Sure, would be great. Thanks for having me today. My name's Adam Simons, and I am the head of sales and applications teams for ATLIX North America. So I've been in additive for about 10 years. And joined, which was then TRUMPF, which we could probably talk about a little bit today, about 5 years ago, and started supporting the laser powder bed fusion technology and equipment. So ATLIX is now a company that recently split off from TRUMPF. We're globally headquartered in Schio, Italy, and we're in the process of moving our U.S. headquarters down to Dallas-Fort Worth. So expect to be online a little bit later this year toward the end of summer. We have about 100 plus employees. We include all aspects of supporting laser powder bed technology within our company. So from R&D and development of machines to production to sales service and supporting different applications with just a sole focus on laser powder bed fusion processes and technologies.
That's amazing. It's been a lot of growth and change, it sounds like, in your company, but also in the laser powder bed fusion market, period. What have you kind of seen changed over the past 3 to 5 years that actually matters to the end customers using this technology?
Yeah, for sure. I think, a lot of different things, but what we've seen really trend in North America specifically is the size of the powder bed, trending larger, as well as the introduction of more lasers in the process. So higher powered lasers, more lasers in order to speed up the production and the processes and make better business cases with the equipment. So I think another key aspect is the kind of maturity of the parameter development as well, and a lot of data being collected and being able to be used more acceptably in different industries. So where you kind of had these early days of struggling through developing your own parameters and did it work? Are we going to get the proper mechanical properties from a part? Right. That's kind of morphed into, okay, now we have real trusted standards around our parameters and enough data to show that, okay, this is working and we are getting the properties we would expect, or at least equivalent to a casting or in some cases after post-processing, a raw part. So it's definitely gained a lot of momentum and just since I've started doing it in the last 5 years, but certainly for the last 10, we've seen those really firm up and those standards become a part of what customers can now use and unlock to use the technology more freely.
Yeah, I love some of the words you brought up. We harp with all of our guests on this podcast where production-ready additive system isn't just a technology. And I love your point around, I need good data. There has to be a business case. You need standards for how you do things. When you talk to customers, what does a production-ready system actually require today?
Yeah, I kind of like what I just mentioned, the machine has to be fast enough and affordable enough that it makes sense from a cost perspective to approach it. But there's also a fine line there. I think, we've seen systems introduced that have, 16, 20 lasers. This is able to make you go faster, but it does increase the cost of the machine as well. And it increases the complexity. And is our process chamber, maintaining the right conditions across different part families in the right way? I think there is a sweet spot in there where you can have enough lasers and enough laser power at a good cost to really maintain a stable process conditions and get that repeatability and quality build after build. And that's been, I think, ATLIX approach. Introduced a new system last year with quad 1 kilowatt lasers and with proper gas flow and things that we've been able to do in R&D that really show that, yes, we have good process conditions that are repeatable, that are fast enough, and we can keep the machine cost low enough that it's able to be used and to make many business cases in production. I think monitoring capabilities as well. So one of the things we focused on is, okay, how do you monitor the process? But then you also have to check the quality of the part during the process to make sure that that consistency remains without a lot of additional cost on the back end to inspect the part and CT scan the part, and all of those things kind of add up and can kill business cases pretty quickly.
Yeah, completely agree. We always share that with folks where if you have 100% inspection on the back end, your economics don't work. You're going to have to be able to have a repeatable process, repeatable technology in order to make that happen. I want to shift a little bit from the technology to the people running it. When you see an additive initiative fail or succeed inside your customer's context, what do you think separates the ones that scale for the ones that don't get past what we call pilot purgatory?
Yeah, that's a really good question. I think that from the get-go, it's important to look at additive as a tool in manufacturing and not something that you need to use, but to use when it makes sense. And I think when we look at customers that are successful, they choose or are in industries where additive adds a lot of value, because the part geometry are things that you just can't accomplish through other means, or the volume's low enough where it's like, okay, this is not making sense to go for a casting style or other method. And I think when we look at, if you want to scale from something that's a pilot part to something that is large volume, choosing parts internally that are able to be scaled easily. Anyone can probably produce a part with enough time, effort, resources, and energy to get one really amazing part out of the system. But then when you go to scale, it's like, well, yeah, it took us a week to depowder this thing correctly and another week to get it machined. And then, okay, now we have to do 20 of those or 30 of those or more a month. How does that look and how does that work? And often it doesn't. The economies just aren't there. So I think taking in all those considerations from the beginning and choosing pilot programs that are scalable in that way is the customers that succeed. And the ones that don't are the ones that put a lot of effort into making an amazing part and making it work, but didn't really think about all the things on the back end that come with scaling.
Yeah, that's such a salient point to think about all the downstream processes that add up as you scale. And I think it's part of this conversation shift happening where you're moving from innovation to operations. I'm sure you have
Mhm.
customers and they're bright people. You wouldn't be in those roles if you weren't, but helping them make that shift from, I have an R&D mindset, I'm going to brute force it till I get it done, where we see additive, those folks are attracted to the industry. But then translating that to all of those considerations you just talked about, post-processing, workforce, tack time, et cetera. How have you helped
Mhm.
customers navigate that conversation, maybe their mindset shift internally, and then communicating out to their executive team, their workforce, to bring the organization along beside them?
Yeah, another really good question. I think, when we talk about scaling, it's more than just adding more machines, right? Or adding more equipment. There's also a level of expertise at the operator level, and really being able to see that consistency in how people operate each piece of machinery, and having consistency there, I think is a key component to this. We've seen cases where, you have a really good operator on the machine and now it's time to add additional machines. So you go and you hire. And then you bring in that new person, you train them well, but they're not doing things exactly the same, or they're doing things differently enough where you're not getting consistent results from the machines that are scaling with the project. So I think from a training perspective, it's important to not only give the proper training, but to also monitor, how people are setting up over time, and making sure the leadership is there kind of overseeing that scale and that growth. That's more from the operator side. From the part side, it's kind of the same what we just talked about. Okay, this is how we're going to depowder one part. How do we batch process 20 of these parts in production, right, as we scale, and do that in a cost-effective way? And I think that takes a larger organization to look at with ideas of, okay, we're fixturing the part differently. We're going to use this different type of equipment that will help us batch these together. And we see that kind of shift. And that's where we've been able to help customers to as they get there, because we've seen a lot of things. We've developed a lot of things, but we also develop alongside our customers and kind of help them through that process of growth.
Mm-hmm. Yeah, I love your point about operator. I hire one rock star, you hire two. What's the difference? I was just on a conversation yesterday, and big Fortune 500 manufacturing DNA, but had implemented an additive program, and they were sharing that they had brought in engineers who had set up a beautiful process, had been getting great parts, but their natural inclination is not to sit and do a same process the same time, day in and day out, where you're cleaning parts and you're
Hmm.
cleaning parts, in the polymer world. Those folks want to be designing and creating whatever comes next and doing new product
Yeah.
introduction. And so this idea not only of are you onboarding and monitoring effectively, but also do you have the right person in the right seat on the bus? Because what it
Hmm.
demands operating at scale is totally different skill set than an engineer who wants to leverage additive to help design a part differently.
Yeah. No, completely agree. It takes, you know, to think that you're going to there are applications out there, right, that you can just pull the part off the printer and put it in production. But I would say 70% or more of the parts we see, they do require, that team, the post-processing of it. You have to align with, the machinist in your building to figure out how you're going to machine this thing. It'll require heat treatment, all of those different facility requirements. And it's not feasible to think just one or two people can accomplish the whole process chain.
Mm-hmm. Yeah, and that's, underestimating, I'll call it the organizational cost of additive, not just my CapEx in adopting my machine. Are you
Right.
seeing any other types of underestimation of what it takes organizationally to be able to adopt your technology other than the ones we've talked about so far?
Yeah, I mean, it comes down to the application
Mm.
and the industry requirements that they're supporting. I think there's a full spectrum out there of different things that people have to do to parts to make them qualify for what they're trying to make them perform in the field. But in most cases, printing is only 30 to 50% of the cost. It's the other stuff that you have to consider to make that a viable part, that you have to say, okay, in order for maybe the part's perfect for AM, maybe the cost is right for printing it this way. There's a lot of advantages there, but do you have the right either resources internally, the right equipment, the right people to take it from the printing process through the rest of the way? Or do you have the good supply chain around you that's going to help you do that and in a cost effective, quickly way? What are you gaining in the end? And I think that's an assessment that a lot of companies are making right now. And like I said, there's a full spectrum depending on the risk of the part. If you're making, dental frames, it's not the same as making flight parts. So there's definitely different considerations to take when you're looking at, is this right for our business? And a lot of that goes along with the industry that you're supporting.
Mhm. And when you're helping customers through this, you're qualifying the parts, you're qualifying the process, you're helping them understand the change management portion. Where do you see some of the biggest talent gaps or workforce needs to be able for organizations to bring this to life?
Good question. I think it's, machining additive parts is certainly different than machining blocks of stock. So it takes a certain skill level from a machinist standpoint to look at a part and machine it to tolerance. It's difficult. I have seen many machine shops just think that they can adopt this like any other approach, and they're not successful. And certainly when you have parts that take 2 weeks to build in the printer, and you have kind of one chance to machine this in the end, or it's a loss of a month of time, the pressure's on, and it's not something that you can just mess up and then grab another block off the shelf and redo. So that's a certain skill level that I think needs to get more in tune with how to machine additive parts, would be one of the bigger gaps that I see. I think in depowdering too. Not everyone in the design and product level is thinking about depowdering a part. So they'll design something that's really, really good for AM, and then they go to get the powder out, and it's really challenging. And they're using all sorts of different techniques to try to get this out. And whereas if they thought about that in the front end, maybe they could have designed things differently to powder this thing in a proper way and in a quick, efficient way. Operator training, I'll go back to that as well. I think this is getting better, but still certainly something as this technology is new. There's still some, as you said, rock stars out there, but as it scales, we're seeing more and more students out of school, coming out of school now with good experience around running laser powder bed, which is a good sign. So I'm seeing that get better, but still a potential gap in the short term.
Yeah, I love your point that DFAM isn't just designing for additive manufacturing writ large. It also
Right.
includes post-processing. I think that's such a great point. And thinking about, machine shop, standard capabilities, how do they apply to additive? Do you see this gap between what I'm going to call quote unquote traditional manufacturing teams and additive manufacturing teams? And how do you kind of help that cross-pollination?
Yeah. Well, I think it's easy when it's all internal. So we've seen a lot of the more successful, I'll say, service bureaus or contract manufacturers out there that are taking on additive in a really serious way. A lot of those companies have the internal capabilities, and since this is their main focus in a lot of cases, they're able to kind of communicate a lot better than, let's say, if you're outsourcing machine work. So if you have that ability to do both in-house, then you have a big advantage, I would say. If you don't, then I would say, trying your best to kind of include your subtractive manufacturing suppliers in early stages of design or in early stages of the process of printing prototypes, even as early as possible. What do you guys need to be more effective in machining parts like this? Or what concerns do you have? And kind of having that open line of communication and doing it as early as possible, I think is pretty critical. And we see that successful contract manufacturers that do all this in-house, they are doing those types of reviews, I think, early on. And that's what's getting them parts out the door faster.
Yeah, I mean, supply chain's so big, and it's not as simple as I just need a more resilient supply chain. I need to onshore and nearshore this. Your point about what should be vertically integrated. Is this core to the capabilities that I already have separate from
Yeah.
additive, or is it better outsourced? And if it's better outsourced, there might be a whole different set of partner qualification questions like the ones you're asking that aren't
hmm
how long have you been in business and can you machine this part, but it's how are we going to get
hmm
aligned on requirements, on process, on communication. And I think it's important, and it's not always top of mind when folks are trying to bring a part through this process or any other.
Yeah, it's to that point. It's when you're in the early times, you don't even necessarily know what supplier you're going to go with. So it's not always feasible to go and bring every supplier that you're considering into the early days of the mix, because that slows you down as well. So obviously, if you can get one or two key ones in your network that you have trust and rapport with, and they have good capabilities, that's a huge plus too. But a lot of times you just don't know in the early days, and makes it difficult.
hmm Yeah, we've talked a lot about tech stack and business case and how to pick the right application and then run that through a repeatable process. What I love to do on this podcast and what we get a lot of feedback on is take this level and break it down for me. So if you were meeting a new customer tomorrow
Mhm.
and they're looking at adopting additive, they're looking at your technology, what would you walk them through? I'll call it from how to choose the right application and business case through what we're
Yeah.
talking about internally source all the way through setting that system up and implementing it.
Yeah. I approach new customers with a very open mind. I never know what they're going to be proposing or thinking. You could look at a customer's website and be like, "Oh, they probably want to do this," and you go in and talk with them, and they have completely different ideas or things that they're considering for AM. So I think step one for me is always walk in with an open mind, know enough about their business to maybe propose some ideas or things you've seen, but also get a sense of what they're thinking early. And I think the companies that are successful engage about different parts early on with experts and with machine OEMs, and what have you seen, what is possible. So really understanding the goals of the organization, why they're even considering AM, and what parts are you considering and why are you considering those parts. And red flag if they don't have any goals. If they're just like, oh yeah, we think we'd like to print this because we think it's faster, and it's not always faster, right? And sometimes you have to walk that path with them. But if they're like, we have a lot of these failing in the field because of the way it's designed, and if we designed it this way, we would have less failures. Like they really understand the problem with the part and why they want to improve it and why additive could be a fit for that. And then we can kind of examine those parts together. Just really defining goals with them if they don't have any, and seeing what makes sense, and then kind of tying that back to what's the benefits to the business if these goals are achieved. Okay, you'll have better performing parts, so you'll have happier customers. You'll have less failures in the field, so you'll have less service calls and all of those things. That's where you start, I think, to develop your business case and your ROI for potentially printing these. And then looking at all their alternatives. How else could you manufacture this part? You know, in some cases, it could only be developed or manufactured additively, which is great. If that's the case, then kind of looking at, okay, what your throughput needs, what your volume needs, running some simulations, determining if the throughput is viable on a machines or how many machines it will take. And does that cost make sense from what you'll gain from the business? That's classic kind of steps. If it can be manufactured alternative ways, don't be afraid, I guess, and I'm never am to say, why aren't you doing it that way? Why don't you cast this? Why don't you machine it? It's obviously better, and maybe they have reasons why, or maybe they don't. But I think it's important for them to, if you want to make a business case for AM, you kind of have to rule out all the other things that are in your building on how you can make this part where you've already sunk costs and investment. And there are some home run applications out there that just make absolute sense for AM, and I think those are the ones that ultimately get the money and the investment and the focus.
Yeah, I think you hit the nail on the head. Additive can be exciting and customers can say, can I print this? And instead it's, what's the best way to make these parts? And I share a very similar philosophy to you, Adam, where if it's not 3D printing, don't do it, because what you want to do is
Exactly.
build trust. That is your currency. Your currency is trust. And if it's, I'm going
Mhm.
to go to your point, parts fail in the field, I want to reduce my support and service calls, whatever it is, better patient outcomes. That is your promise. So make sure you can deliver on that. And then when you go ask for round two, maybe it is additive. That's going to be much more well received when they trust you're making the best decision for the business. And I love that you shared that, and you shared a lot of business goal, strategy, customer focused questions. Obviously, there's a lot of technical folks and technical leadership that gravitate towards additive and that are propagating that across their own organizations, but they need to be business people too. We say that here all the time. Like, we're a business
Yeah.
full of business people, no matter where you sit inside this organization. And I think that's a great point.
Yeah, it's a lot different than, let's say, 10 years ago, where there were investments made just because, hey, we want to get into this and play with it and see what we can do. And sure, we'll throw, half a million, three-quarters of a million, $1 million at this just to see. And I think, it proved to be a not great strategy. And definitely now, fast forwarding to today, no one's making those investments just based on the technology being cool and they want to see what they can do with it. They really want to figure out how you make money with this. And I think, that's where me and my team, we can help a lot, because we can kind of also point out the pitfalls that we've seen, and maybe pointing out things that they'll need to invest in addition to just printing, that they'll need to consider. And I know our customers appreciate that. And ultimately, we do find good applications if they're digging deep enough, and we do, work together. So it's a good time to be an AM, especially metal AM, because it's much more serious now than I think it's ever been. And at least in my time and working with the tech.
Yeah, I'd agree. We were on a podcast a while back, and it was actually, he headed up additive at Crown and then is at Rico. And he said, I will know additive has succeeded when it's boring. When I take people on a tour and they don't want to see the additive lab, they're just looking at a manufacturing plant. And there happen
Yeah.
to be, additive solutions there. And I think to your point about being serious is really critical. We talked about that on an operator level, on even like a technical leader, head of AM level. I want to helicopter up because we have a lot of executives that listen to this, a lot of people in the C-suite. How should executives be thinking about what are the top 3 questions they should ask when investing in this technology? What are the top mistakes maybe you see other execs making that they could learn from?
Yeah, I think it comes down to the goals of the organization and the specific industries. But in general, if you're really looking to start and scale this technology, I think it's as an executive, you have to set realistic expectations and not expect things to just snap into place overnight. It is a maturing technology, but it's still relatively early days in adoption for bringing in a metal systems. It's not the same as adding another press brake or CNC machine. Things are going to happen. All the things that we just talked about with the consistency in operator training and how they handle the equipment, how they set up the machine. That stuff takes time. So as part of your business case, I think it's important to set realistic expectations, right? Pick things that are I don't want to say easy, but easier than your hardest part in the building, and try to scale with that before you try really, really difficult, challenging applications that are, super high risk. Unless you have that kind of groundwork already. But if you're starting out fresh, I think it's important to set realistic expectations and kind of build your processes and your personnel and your supply chain around, as you gain confidence in the technology in your building.
Yeah, I think that point is so good around risk and opportunity. I mean, that mindset exists in literally any other technology you bring in. I don't care if it's AI or AM,
Uh-huh.
and to your point, don't leave that mindset at the door just because it happens to be a 3D printer. You wouldn't make a business decision about any type of innovation coming into your building without that matrix of risk versus reward.
Uh-huh.
Use that here is a
Exactly.
really good point. We talked about a lot of things. There's a couple questions we always like to leave on. So if you're a manufacturing leader and you're listening to this thinking, all right, I get it. Now what? What is the first move you would actually make?
This ties in perfectly to everything that we just talked about. I think it's okay. Are the parts we make good to be printed, or are the things that we want to offer our customers good to be printed? And if you don't know, there's plenty of resources out there that you can engage with to kind of determine that. And then the second step, in my opinion, would be, what are the goals? Why do you want to print this? Not just, can we print it? Oh, okay, great, it can be printed, but why do you want to print it? What are you trying to accomplish by printing it versus how you're doing it today or an alternative? And if you kind of have goals that fit to the additive technology, and you have parts that can be printed, or you have new ideas, new concepts that you want to bring to market that are better suited for printing, then I think you have the right frame to then go and explore what printers or what specific method of 3D printing will be best to produce these and get what we want of them, and then evaluate them deeply to figure out what's going to get you the best part at the best cost. And then as a next step, what resources and people do you need around you to make it work in your building? And just what we talked about, setting a realistic expectation, a realistic goal. Don't try to snap your fingers overnight and go from manufacturing something one way today and AM tomorrow. It never works that way. Give yourself enough runway to be successful. And then you can, once you're comfortable and you're successful in a project or two, it's going to scale. You're going to get more projects going. You're going to have other people in the facility and in the building want things printed, and maybe new projects come along where, okay, this is proven. We have a lot of trust in it. And you can evaluate those and really grow it from there. So kind of great question to end with. I think it ties into everything we talked about in a nutshell. It's just setting the right goals, picking the right parts, putting the right people around you, and starting small and growing.
Yeah, that idea of context is so critical. A lot of times people will say, well, I picked this part. Well, why was it designed that way? Why shouldn't it be? Why should you use additive? And so ending on this note of context when you pick, when you print, and when you scale. Adam, it's been such a great conversation. I think that our listeners will get a lot of utility over the pretty practical takeaways that you shared today, as well as some of the ethos and philosophies to help them be successful. So I can't thank you enough for joining us.
No, really appreciate you having me. It was fun. Happy to come back anytime.
Well, that was an interesting conversation.
It was.
So what stood out most to you from that conversation with Adam?
Some will be a familiar theme where scaling is not adding more printers. It's about this idea of operational consistency. But I loved he brought a financial element into it. And he said printers are really only 30 to 50% of the cost and not upfront cost, ongoing operational costs. We've talked a lot about why consistency matters so much in terms of scaling into production, but I think being mindful that you need to scale the resource around the whole back end of that process and look at operational, not just from a consumables that my printer may need, but all of the people, processes, inspection around it was such a great takeaway.
You know, I was encouraged to hear him bring that up because far too few people, there's a lot of focus on the CapEx, right? Because in most organizations, you got to write up a CapEx approval. And in today's economic environment, that takes, however many flaming hoops or hurdles or whatever that your organization has in place to get approved. But the ongoing cost that is usually people, sometimes automation and systems, but is so frequently overlooked. And without someone who can help guide you through that, it's easy to sign up for more than you bargained for. Also, this concept of pilot purgatory
Yes.
came up there. What did you take away from his insights in terms of why companies get stuck there, and how is that similar or different from what we've seen so far?
Yeah, he said a lot of companies start and they want to optimize around, can I print this part? Not does it scale economically? And some of those costs we just spoke about in our takeaway here. But he goes brute forcing a prototype, making it through the whole process, and then realizing you have 100% inspection on the end, destroys all of the economics that it took to get there. And that's not even accounting for what do I need for post-processing, process, labor consistency, training, development. We say that often in the polymer world, that you can't have 100% inspection or the economics don't work. You need to have, some type of sampling. But to hear that unprompted from him, and his worked with so many customers getting this through. And this idea that you begin with the end in mind, and the beginning is not optimizing a part to see if it can be printed. It has to be, the end is, can I scale this economically all the way through my value stream?
Yeah, it's amazing how some of those themes that you and I have beat the drum on over and over, come up when people have had to actually do this at scale. Those same lessons are so valuable. He also talked about, again, we mentioned it's hard to do one of these episodes and not have workforce come up. And I think there's a lot we can learn from it. We may do a whole episode just on the workforce elements of additive, but Adam talked a lot about that and this whole operator consistency, workforce readiness. Why is that so important?
Well, it's interesting. It's not only super important in terms of where you are in the process, but it's also important to think about what types of roles and functions attract which type of people. So we spend a fair amount of time talking about people that are in new product development, new product introduction. They tend to be engineers. They're innovative. They want to be able to design the next new thing. And an innovator is not necessarily the same DNA as an operator. So you'll get someone that will have a part, do a beautiful design, get it through this process once, think it's a slam dunk, spike the ball, transfer it over into production, and that same person doesn't want to have an attention to detail that involves following the same post-processing steps each time. And I need to make sure that not only am I consistent, but there's not a lot of novelty. In fact, novelty is going to destroy profitability in this context. Yeah. And so we talked about this inventor mindset versus more of a production mindset, and how you not only need the right onboarding and development of the tasks, but you need to be intentional about the people you're putting on the bus and what seats you're having them as you move additive from this pilot stage into something that's more sustainable in production over the long term.
Well, I think there's a tremendous opportunity there. You've done a good job, and Adam did a nice job, highlighting the risks, the opportunity. And I would relate it back to, the AI workforce disruption that so many industries are seeing when we've got this huge manufacturing renaissance happening in America right now. Where are those people going to come from? And depending on if you're listening to Lou Dobbs or Mike Rowe, the however many millions of manufacturing workers we're missing, that the numbers differ, but it's a lot more than 10. Yeah. When you think about what is going to attract the workforce of today and tomorrow into a manufacturing job, advanced manufacturing technologies are a great way to do that. And I think companies under-leverage that and don't recognize there's a time to treat additive like everything else. And when you're planning QA/QC strategies, et cetera, supply chain strategies, treat it just like you would everything else in your plant. When you're thinking about how am I going to write a job description, recruit, train, retain this workforce that I need, that's a time to put a little marketing hat on from a recruiting or talent management standpoint and leverage the fact that this isn't, the old description of manufacturing jobs. They were dirty, dangerous, and there was another D, I forget what it was. Again, there are risks, but on the other side of that coin, there are opportunities that oftentimes I think companies don't take advantage of. Another part that I found fascinating was, Adam's commentary around executives and expectations.
Yes.
Give me your thoughts on his take.
Yeah, he said if you think that the shininess around additive being a magic box has worn off around operators, 100% has not once you climb the ranks. It's a little bit like AI or AM, and we talked a lot about the similarities there where it's a wonder tool where I should see results immediately in any process I do in terms of, I'll call it a risk management or opportunity identification filter. I don't need that in additive. And so we talked about setting expectations starts with what am I doing when I implement additive? What business problem am I solving? What quantitative outcomes can I expect? And I don't mean, I don't have to have 100% inspection and this part is 3 times cheaper and I get it to market 2 times faster. But things like, you know what? When I have this part in the field and it fails, my support tickets go up by X. I have some idea of what ROI would look like to solve this, and I'm going to back in my way into the right application from there. And being intentional when you're talking with executives and executives being intentional on the timeline to see results and what they're driving towards, he just kept going back to, you need to help them understand the problem you're starting with, which is not, we should implement additive as a strategic capability. It should be, what are my top 5 problems and how can we leverage additive strategically to solve them?
Makes complete sense. So to put a bow on all that, what is the biggest takeaway if you were a manufacturing leader that just digested this episode? What are the 1 or 2 biggest things that you would walk away with and go implement tomorrow?
They're going to love this because they're not technical, but it's start with those business outcomes, not the technical capability. And I'm not even talking about which printer should I choose. I mean, don't start with the technology at all. Most of the successful programs that I've seen that Adam and I talk through start with that business outcome in mind. And whether that is, maybe I do need to have a new revenue stream from customers that I say no to because my profit margins are being squeezed over here. Maybe that is, I got to work on my supply chain because it's terrifying to be single sourced in this current manufacturing environment. Or like the example I just gave, I have a part that keeps failing in the field and it's just killing my customer satisfaction. But you have to start with that and then don't pick the impossible part to do it. It sounds cool and exciting because no other manufacturing technology could produce this geometry. Correct. But that needs to be a downstream filter, not your selection picker. You really need to pick something that you feel like you can win with, because we talked a lot about how it may feel like the scariest currency you're trading is that CapEx request, but it's trust. And your organization needs to know when we come to you, you are thinking, what is the best way to make these parts? And you are saying, no, it's not 3D printing. Whether you're a machine OEM or you're operating this in the field, saying, no, that's not the best fit is actually sometimes the best thing you can do to maintain that trust upstream, downstream, and across the organization. So I think that he left that as, one of his biggest takeaways. And I would just echo that when you're thinking about being a manufacturing leader and what really is my job. It's to find the best way to make these things. It's not to implement additive every time you see a potential geometry opportunity.
That was a tremendous sermon. I feel like we should take up a collection.
Thank you for coming to our TED Talk.
No, great job. Powerful stuff. Looking forward to the next episode. You can follow us on Apple or Spotify podcasts. You can watch this episode on YouTube at the Additive Advantage Podcast. And if you found value in today's conversation, a 5-star review on Apple or a 5-star rating on Spotify really helps us keep this thing going. And make sure to follow us on LinkedIn so you don't miss new episodes. Thanks for investing time with us, and we'll see you next time.